your VCE, the voltage across a collector emitter, is equal to the supply voltage, and I mark as Y. Okay? So once you mark the 2 points here, one X and the Y, you join the 2 dots or 2 points and you have the, and you start to see that it's a DC load line. Okay? Any question from anyone regarding the DC load line first? Because you really need to know how to find the 2 points first before anything, or else the rest very tough. So now up to here, I already draw the DC load line and how to get the 2 points, namely the maximum collector current, all right, at the X, and the VCE max equals to VCC, which is a point Y. So you need to find out these 2 points to join, and before you cut across the curve to get the Q point. Pause for 3 minutes. If you have any question, I can always repeat. Okay? If you want me to repeat, just let me know now. Or you think about it in 3 minutes time, you can still ask me. We pause for 3 minutes. Okay, 3 minutes up. Any question from anyone? You want me to repeat any part of the notes? Let me know. Or anything to clarify? Okay, if no question, I continue from here. If there is, just use your mic and stop me. Thank you. Okay, so up to here, we have just drawn a load line, or rather a DC load line here, right across. Of course, how we get this line, we have to find out this point to look for the maximum collector current, which is given by VCC over the resistance. This is basically Ohm's law, okay? It's just like I equals to V over R. Okay, then we get 1 point. I do a quick recap. Then the next point that you need to get is Y, which is actually VCE equals to VCC. That is when there is no current. That means, as I mentioned, the transistor is not conducting. All right. Then the voltage across the collector emitter will be equal to the supply voltage. So the moment you get these 2 points, namely X and Y, you join them, and then you cut across the curve. These are the characteristic curve of the transistor. I'm coming to that later. At the moment, just these 2 points first. And of course, from here, you see that they take the middle characteristic curve, the point here that they cut or intersect, and they call it a Q point. All right. So from this diagram, you learn about the saturation region, the active region, and then the cutoff. Okay? Or if you cannot recall, I bring you back to the beginning here. Yeah. Just now this. All right? They didn't really tell you the details, but now when we start to construct the load line, you find meaning relating to these 3 regions: the saturation, the active, and the cutoff region. Okay, so from drawing the load line, you start to understand what does it mean. Okay, we started from here analyzing the circuit. I asked you to look only exactly at this branch. All right, the rest ignore, and then we go on from here. All right, and get the 2 points and join them together, and that is the DC load line. Okay. Yeah. Okay, so back to here. Yeah, I just show you the 3 regions: saturation, active, right in the middle where the Q point is, and then of course the cut-off region where the transistor don't conduct or is not working. Okay, and okay, can you all please take note of this also? Something for you to know, also important. It said if there is no emitter resistor, imagine they are talking about this circuit here. All right, they're saying that imagine there is no emitter resistor. All right, okay, imagine it's not there. Then now your equation becomes simpler. It becomes ICRC plus VCE equal to VCC. Okay, that will be your load line equation. Okay, can take note, that is provided or there is no emitter resistance. Okay, so the only resistance left is your RC. Okay, the only load resistance or transistor is only RC. And that's how this equation comes about. Okay, so no more RE. The emitter resistance is not there. All right. Any question? Anyone can speak up and stop me now or clarify. If not, I continue. Questions? No? Okay, I move on. Okay. We just saw the Q point, right? We just 4.2. We just saw the Q point on the graph, all right? So they also mentioned to you it's about in the middle of the load line. Later we'll come to that. So it allows for maximum output swing. That means you will see the entire output signal of a sine wave. Okay, that's what it means. All right. Okay. Then the next thing, the simple thing to calculate after you get the so-called Q point, you can calculate the current gain at DC, static, and then you get ICQ over IBQ. Now, the moment you see ICQ and the IBQ, the Q, meaning that you are talking about the operating point, the Q point. Okay, the Q point. Yeah. Okay, that's why we are talking about static DC current gain. All right. If there's no Q, that means it's not, it's AC. So this is the static DC. All right. And is the current, okay, bring you back, where is it? Some of you may ask, this is where it is. ICQ you get from here, example. All right, after drawing the point, you project down, you cut across, you get the value ICQ. You also project downwards to get the value of VCOQ. All right. That's how the value comes about. All right. But this one don't apply to a formula. So you have to be careful. We are taking on this one. Okay, because we are using this load line. Okay, ICQ over VBQ. All right, this one and this one. Don't worry, when you come down further, we have examples we can work out, and then you will get better understanding. Okay, Ken, we move on. So that's how you find your static DC current gain by getting the values from the Q point, which I just shown you. Okay. Now is the time for you to draw and then understand even better. Okay, closer a bit. Right. Okay. So this is an example. I hope you follow me closely once. Then further down, the rest you know what to do. Okay. Are you ready? Okay, this one I must get some of your attention. Can someone reply me? Are you all ready for this? Plotting the graph. Yeah, okay, thank you, Jessica, for your reply. Okay, I will start so that you know exactly what to do. Then it's easy, but if not, then very tough. Okay, start now. Okay, sorry. Okay, first of all, I want you to look at the table given first. Because sometimes this table given, you may not understand, what is this and that. So I think I better clarify first, so that we are all looking at the same thing. All right, if not, it's very tough. Okay, I start now. Right at the top here, this column is about voltage. What voltage? The VCE, collector emitter voltage, okay? Don't worry, whatever value they give you, you just take note. So it's 3 volt and 9 volts, okay? Now, here, this second row here, you see that there are different values of IB, right? 20 micro, 40 micro, 60 micro, and 80 micro. Okay, take note first. Now, they have different values of IB, the base current. Okay, these are the base current. Now, then you look at the top. They say collector current. Now, this is the meaning of this. This is the collector current. Okay, this is the IC, collector current. Okay, Ken? All right. Are you okay first? This one important before I go to the graph. If not, I go to the graph, you don't know where I get the value from. Okay, these are all the IC. Okay, collector current. Okay, this one. Okay? Question? Never mind, I go on first. You can still ask me again. I start first. Okay, listen very carefully. If you follow me once, twice, 3 times, I think you are able to do it. Okay, first, I think all of you have probably drawn a graph before. Yeah? Okay, first of all, the graph is about IC, collector current in milliampere, and of course, VCE, collector emitter voltage. Okay? IC at the y-axis, VCE and the x-axis. Okay, so I use this scale to tell you, I just put a draw ready for you to save time. So it's 2 volt, 4 volt, 6 volt, 8 volt, 10 volts. This is my scale. Same I must do for my collector current. I use 2 square as 1. So 1 milliamp, 2 milliamp, 3 milliamp, 4 milliamp. Okay, can Okay, so now I will start to draw the curve using whatever is given on the table here. Are you all ready? Okay, can we please look at the first column here of the IB is 20 milliamp. Sorry, microamp. Okay, IB 20 microamp. Then they say at VCE 3 volts, collector current, I use the word, I speak a little louder. Collector current is 0.91. Okay, can you follow me? They say at 3 volts, the collector current is 0.9 milliamp. Sorry. So, first of all, I look for 3 volts. Where is 3 volts? 3 volts is around here. Yes? Correct. So 3 volts move up. Then they say my collector current is 0.91. So about here. About here. Very close to 1. So I draw the line. Okay. So then I have my first point here already. I have my first point here on the graph. I pause for a while. Please ask me if you are not sure, serious. Because I want to move on to the rest so that you know how to draw. If you know how to draw 1, 2, I think the rest no issue. Okay, I repeat. Can all of you understand how I get the first point on the graph here, which is coming from here? I'm looking at the IB equals to 20 microamp. Collector current 0.91, VCE 3 volts. So my VCE is 3 volts here. Yeah, I project up. I get 1 point first. Then the IC, the collector current 0.91, I get from here, I draw across. I have 1 point here already. 1 point drawn. Are you okay? Before I continue the next point, then we will complete one curve already. Very easy. Chen Xian, any questions? Are you okay with the first point of the graph? How I get it? Okay, Ken, thank you for your reply. Okay, then I continue. If you follow, you will get it. Okay, I already settled this one. 0.91 and 3 volts. I get 1 point already. I circle. So I need to get the second point here. Second point, they say I'm still at this column at IB equal to 20 microamp. The second point, they say what? My VCE is 9 volts. Right? And my collector current is 0.99. Okay, one thing at a time. VCE 9 volts, where is it? About here. Yes, about here. 9 volts. Yes, so I project up. I move up. Then the next moment, I look at my collector current. They say 0.99. Okay, easy. I come to my collector current over here. 1 is here. So 0.99 is very close to 1, right? Yeah, so from there, the collector current I project and the VC I project, I get my second point. So, my dear friend, I got 1 point here, I got 1 point here, and then I join the 2 points. And that will be my characteristic curve for my base current at 20 microamp. The first curve. over here, right at the top here. First curve. Okay, I settle already. Okay, I give you 2-3 minutes to digest the first curve. Because as I said, I no point I keep telling you the rest if the first one you don't understand. But if you understand the first one, the rest is just the same. So I want to give you a few minutes, all right, for you to look at it, digest. If not, then just let me know. I can always repeat. For the first curve for IB equals to 20 microamp on the side, which I wrote there. Yeah, that's the first curve drawn. How you get your first curve? Because you have 2 points and you join them together. Okay, I pause for 5 minutes, can? Of course, meantime, within these 5 minutes, if you can look at the second and third curve and you manage to get it on your own, I say wonderful. Solve the problem. Then you fully understand how to draw all the characteristic curve. First thing first, before we move on again back to the DC load line. Okay, I pause for a while. Okay, all right, we are back. I hope you try it out on your own, or at least take a look how the 2 points are all given and plot it. All right, if not, I can continue now. Okay, let's continue the second point now. Okay, so we already plot the first curve for 20 micro. So now we want to plot the second curve for 40 microamp for base current. So go back to the table at the top, and now we look at IB equals to 40 micro. First thing, okay, just leave it first. And now we have, as usual, excuse me, we look at the VCE and base current. So same old thing, the VCE is 3 volts. Here, this column, the first column here, VCE, I repeat 3 volts. And I go back to my 40 microamp here, IB, the value 1.6 here is actually the collector current, 1.6 milliamp. So first point, 3 volts. Here again, VCE, all right? But now your current is 1.6 milliamp. Now on the y-axis IC, you look for 1.6. Now here is about 1.5, yeah? So slightly above is 1.6. So I can say that I can draw a line from here, let's say 1.6, and come to here. And 3 volts, same thing. I can have a line drawn up. Yeah, same as just now. Okay, and then I will have 1 point already. Are you okay? It's the same as just now. That's why I say you know one, you know the rest. Okay, I move on now. So I get 1 point settled already. Yeah, I get this one, 3 volts and 1.6. Now, very simple. I look at the next value of VCE. They say 9 volts. Right, 9 volts is here. You know where is it already, VCE? 9 volts. Yeah, and then now your collector current is 2.04, very close to 2 milliampere, right? So I come to 9 volts. Same thing, I draw one line down, I project down. This is my 9 volts. Yeah, and then here 2 volts or 2.04, very close to 2, right? So I just draw a line. Imagine, I take it as 2 volts. Okay, easier for all of you. Then I will project out this value all the way until here. Yeah, then I get the second point. First point already got, second point got, so I just draw and join the 2 points, and then of course I resettle for IB equal to 40 milliamp. Are you okay? So I have already done this one and this one, and now I left with the 2. Can you look at the third one? Where are the points that I marked? 1 point is here, 1 point is here relating to IB equals to 60 milliamp. Can you get these 2 points? Do you think you can get them? Any question?
No.
Thank you. Okay, no question, I move on. As I say, we are done for the first 2. Now IB equal to 60 microamp, which is this curve which I draw beforehand. But the same thing, method we use to get the 2 points. 1 point is here, yeah, and the other point is here, yeah, before you join them. These 2 points, the value come from here again. We see E 3 volts and 2.3 milliamp. 3 volts and 2.5 is here. So roughly 2.3 is here. I draw the line. I project the line to that point and cut with the 3 volts. I get my first point. Yes. Now move on to the VC 9 volts again, which is here. I project up 9 volts upwards. And now you tell me my current is 3 milliamp there. Okay, 3 milliamp. So very easy, 3 is here. Then I just project off. Correct? After a while, you know what to do. I think very straightforward. Okay. Then I get my second point here. Yeah. So the 2 points I get, I just draw the line, the curve, and this will be for my base current at 60 microamps. Done. Okay, done. I don't think it's difficult if you are following me. Oh, so you look carefully. We are actually concentrating on 3 volts and 9 volts only. Right? You see, all the points here are up here, 3 volts. Here, all up here, all 9 volts. And only different current, different collector current, which is here. Okay. Can someone want to give me the first point for the last one? I already did 3 for you. Can someone just attempt and tell me what is the first point for IB at 80 microamp? The first point. Can try? Doesn't matter if it's right or not, but we need to try that before we decide whether we know or we don't know. Anyone? For IB equals to 80 milliamp, 80 microamp, where is the 2 point? You want to try? Or Jessica? What about Naufa? What will be my first point? For the last one here, where IB equals to 80 microamp. The last column, where will be my first point? No attempts? Okay, then I move back and we will plot it together. Okay, Ken? So can you please follow me first? If you have missed out the 3, but please take note the last one, at least if you know, you were able to draw. Okay, now I'm looking at the last column. And all you focus, last column here, where they say IB equals to 80 microamp. So I need to plot the 2 points to draw the curve for IB equals to 80 milliamp like the rest of the earlier 3. Yes? Okay, so same thing. I look at VCE again, 3 volts, no change, 3 volts, still going up. Okay, but now my IB is what? 3 milliamp. 3 milliamp. So my 3 volt, I still project up here. So my current now is exactly here, 3 milliamp, my project. And then this will be my first point. Wonderful. Okay, that will be my first point. 3 volts. Here, 3 volts up. Then 3 milliamp. 3 milliamp IC draw and cut. And this is my first point. Okay, settle. So now I look at the second point, same 9 volts here now. Look at 9 volts. 9 volts, where is it? Here. I project up again, 9 volts up. Then I look at the current, is it 4.05? All right, very close to 4. We'll say we take it as 4. Then 4 is here. We project the line out all the way. Yeah. I just show you actually, but if you do on your own, you don't have to draw lines like that. I just show you. So 9 volts is up here, coming up from here all the way up. And then on your left-hand side, I see 4.05 milliamp. I think it's 4. Comes here and then it cross. I got this second point now. Done. I only get 2 points to join. Very easy. Okay? So now, just join the 2 points. Okay, same thing. I draw from here. Ooh. My hand is not very steady. Oh my God. Okay. Let me try. Ooh. Suddenly it becomes so challenging. Okay, now I try to shortcut a bit. So this point I join to here first. Okay, then okay, maybe easier for me now. Then here come to here. Okay, can So you see, I complete already. The last one. 1, 2, 3, and the last one, the 4. So the 4 graphs are here. So of course, this will be your IB at what? 80 micro, correct? Okay, 80 micro. M. Okay, I hope you catch it. It's not difficult. If you follow 1, 2, 3, 4, I show you 4 already. Okay? Question before I move on? Anything need to clarify? Zhen Xian need to clarify anything, or Jessica, or whoever, Naufa? And thank you. Okay, so I hope you get to know how to plot this curve with what is given to you. Okay, step by step. Of course, it's not that first time you look at it, you will know, but the important thing you need to pay attention to the table, what is given. Then secondly, of course, you do the plotting on your own. Okay, but I'm guiding you because this is the very first time you see this so-called type of table and the curve that you need to draw. And where are the points and what are the things to look at. I know when you look at the table, many of you may be wondering, how come so many things to look at? Yeah, but I already clarified everything on the table before we start. Okay, so yes. Then, so in essence, you know that the voltage is only concentrated on the 3 volts and the 9 volts only one. Oh, really? Yeah. You look carefully there. VCC 3 volts and 9 volts only. Then of course the rest is your what? IC lo. Your collector current different one. Or for different IB. Right? For different IB, your IC is different. Basically there are 2 points. 1 point, 2 point, 1.2 point, the same thing. Okay? And then you join the graph. I hope this is a good start for all of you. And so that when you move on easier further down. Okay, if no question, I continue. Another example. Actually, I drawn something for you, but never mind. Okay, the next example, same. You are given a circuit, but you realize something now, there is no emitter resistance. So life will be easier in that sense. So what is given? All right, what is given? Of course, the VCC is given. Yeah. And same thing, base current is all here, IB, all right? VCC voltage is here, now. So you focus on 1 volt, right? And 8.5 volts. Then all these, the rest of the value here is all your collector current. All these are collector current. Same as just now. Or is the another way of putting in the table. It meant the same thing. But I just want to clarify for review first. Okay, all these are IB, base current. Oh, this one you don't need to plot. You just write on the side which curve they belongs to. Okay, so when you plot, you only look at voltage and IC, collector current and voltage across collector and emitter, VCE. Okay? All right, so move on. What is given to you? Important, VCC is what? 9 volts. Yeah? So you have RC given, just now one resistor, 1 kΩ, and then they say IBQ is 80 micro. We took note first. This is the base current at the operating point, 80 microampere. Of course, now they ask you to find or rather plot the DC load line and find these two values, VCEO and ICQ. And then also the static, so-called current gain, DC. Okay? Then, so of course we need to plot the curve again. So you realize that I already drawn two here. Okay? For the first two values for 40 and 60. Yeah? Then 40 and 60. Yes? Don't worry, it's the same as just now. It's just that now the rearrangement on the table is slightly different. Okay? So again, I want to point again. I still want to repeat. Attention. So now you try to get the first point. Okay. Where is the first point? Here. Now we look at this rule. Okay, we look at the IB equals to 40 first. First one. Okay? Then you look across here. Voltage VCE or VC, is 1 volt. Where is 1 volt? Over here. 1 volt is here. All right, 1 volt. Yeah? All right. Then next moment, I look at the same row. What is the IC? What is the collector current? You said 1.9, very close to 2. Okay, never mind, I put there 1.2 is here. 1.9 very close, so I project the line here, and then just now you tell me 1 volt, I project up. Then this will be my first point. Sorry, I think I draw wrong. Yeah, this will be my first point. Yeah, okay. Then here, 1.9. Then they say at VC 8.5 volts. Wait, 8.5 volts. 9 volts is here, so 8.5 is about here. I think this one I draw wrongly. This is 9, but they say 8.5 volts. Okay, 8.5 volts is here. So this point is wrong. Okay, so 8.5 is here. Sorry, it's about half. Okay, 8.5 is here. So I project up first. Don't want to confuse you. Ignore my 2 point first at the moment. So I project up first. Okay, 8.5, then they say, okay, what's your collector current? 2.69 or 2.7, very close. So 3 is here. Yeah, 3 is here. So 2.7 is about here, roughly. Okay, sorry, where am I? 8.5 and 2.7, yeah, it should be around here. Okay? Around here. So I just project again all the way about 2.7, and then I hit this point, and then I get my first point here, or rather the second point, and then I draw. So ignore this one, ignore this one. I try to erase, I see can or not. Erase this color. Okay. Okay. Then. Okay, so I get this first point and I get my second point here. Same thing, I join the line again. No? I join and then it becomes the first curve for 40 micro N. Okay? All you okay? Can So okay, I leave you to go and practice to draw this. Alright, I think I repeat enough many times. Of course, you still cannot later you can ask me. So I leave you to go and draw the curve for the rest of for the base current for 60, for 80, for 100, and for 120. Same thing. You need to get 2 points and join the curve. Now I want to move on to, because they want you to plot the DC load line. Okay. So the DC load line, you need 2 points also. Okay. If you can recall, you can recall, we go back a bit. We go back to the earlier part. Where is the point for the here? Okay. So it will be VC over RC because now we don't have RE. Yeah. Okay. I want to get my first point, X, to draw the load line. I hope you are following me. I want to draw the load line now. Okay. So my first point X, I need to get VCC divided by RC to find the maximum collector current. So I go back here. Can someone tell me what is my VCC? 9 volts, right? So I write here, IC. Okay, wait. Okay, IC. This is the maximum value. I better write down. Max, max. IC max equals to what? That's how we saw. Can recall? VCC over RC, right? Okay, we do one more time. Okay, here. VCC. Okay, over RC because now we don't have RE. So come back to here. So will be VCC over RC. Okay. Okay, can someone do me a favor? Can you take 9 volts? Because VCC is given 9 volts. Okay. And divide by 1K ohm. Oops. And can you please give me the answer? Thank you. Anyone? Anyone? 9K, 9 volts divided by 1000 ohms. What is the value? Thank you. No, 1K. Hey, 1K ohm. RC is 1K ohm. RC is given as 1K ohm. RC is 1K ohm. Should be 9 volt divided by 1000 ohms. What's the answer? Anybody? What is 9 divided by 1000? How do you get the 0.081? Because I want to have 9 volt divided by 1000 with 1 kilo lah. Yeah. Can you get the answer? Okay, so if 9 volts divided by 1K, I will probably get, or rather I will get 0.009. Yeah? All agree? This is ampere, ampere. Sorry about the writing. Okay, this is ampere. All agree? Everyone agree? Yes or no? I should get 0.0. Yeah, okay, correct. So now, thank you. So now I change it to milliampere. What should I get? I move my decimal place, right? 1, 2, and 3. I change it to 9 milliampere. Yes? Same, I change, So I get my first answer for IC, the first point. This is IC. I come to the graph now. I look for 9 milliampere. This is 6, 7, 8, 9 milliampere here. So this is my first point for my DC load line. Okay, so this point, I will point to here. Yeah, exactly. Okay, like 9 milliampere. Are you okay first? Now I'm trying to plot the load line, and then I think, yeah, we are almost there already to do the rest. Well, today I take a bit more time because a lot of things to explain. Okay, never mind. We try body can visualize what is the load line. Okay? Okay, can someone make an attempt? I get my first point here now, which is given by IC maximum equals to VCC divided by RC, 9 volt divided by 1.k ohm, I get 9 milliampere. What about the next point at the VCC side? Okay, I revisit. Can you please take a look? I revisit the graph again this morning. Okay, the next one is this is what you want to get. Your point Y. How to get point Y? Yeah. Now this is the point, I repeat, it's called a cutoff. That means when there is no base current. So what happened? They write here. You see here carefully. They say VCE max equals to VCC. Okay? When that transistor is not conducting, no collector current, 0. The VCC equals to, or rather the VCE maximum equal to the VCC. Okay, so now I come back here. I hope you look at it at the same time, then we can close already. Okay, just now they say what? VCE equals to VCC, right? Correct or not? So what is my VCC here? 9 volts. 9 volts, there. So they say VCE equals to VCC is the second point, which is here. This is 9 volts. Okay, 9. And this is the second point. Yes or no? Okay, I just point here. So it's actually V C E equals to VCC. Yeah. Which is this point. Okay, again it's 9 volts. So VCC given what? 9 volts, right on top here. Yeah. Okay. So I have my second point, wonderful. Now I can draw my line already. My so-called DC load line. Okay? Can? So once you get this point here, where IC maximum and then VCC equal to VCE, you just join the 2 point and that is your load line. Okay, I see whether I can draw a straight line. I use a line to draw, I see can or not. Straight line. Oops. Cannot. Oh, okay. Go back. Okay, I try. So you should join these 2 points with a straight line. Okay, just one line across. Ooh. Very tough. I should do something else. Never mind, I can again one more time. I draw half first. Okay, so from here you join. I mean you join this point. Yeah. Okay, not perfect, but it should be a straight line. Okay, so you join the 2 point and then, well, this is your DC load line. Wonderful. Okay, this is your DC load line. All right. Actually, there's a little bit more, but this morning I think we really cover a lot. Okay, so at least we come to the part where we able to draw the DC load line. Okay, actually from there later we were able to find these two, very easy. Okay. Okay, thank you so much for your attention. I know it's quite a fair bit this morning. Any final question before your goes off? Any final question? Or if you have any, don't worry, just contact me also can. Or you can contact me anytime, WhatsApp me or whatever. Okay, if you find that you are stuck somewhere. Okay, if no question, then I will see you on the next lesson. I hope you encourage your friends to come in because as we move on, there are more and more theory. So the concern here, you all know that for AA, it's a type A module, there will be exams. Okay? Yeah, because if your theory plunge, your GPA also plunge. So I hope you try your best to listen up. And most important of all, if you have questions, just ask me. Okay, don't hesitate to ask. I would rather you ask than you keep quiet. Okay, or you are not clear, also clarify. Then as you move on, things is less tough. Because if every lesson you start building question, and you don't want to resolve the question in your head, you will be overwhelmed. Yeah. Okay, I hope you listen to my advice and ask questions as and when you want. Okay, Ken? If no final things you want to ask, then I see you guys in the next session. Thank you very much. I'll see you again. You can sign up from now. Thank you. Okay, bye-bye. See you guys.